Howdy. I just wanted to show off this thing I've been working on. What I've been doing is I've been working on some software written in Python that can talk to my Rigol DS1052E digital oscilloscope. And what I'm doing with it is I'm using it to generate frequency response curves for my amps that I build. So this is an amp right here that I'm working on. This is a guitar amplifier. And currently I got it hooked up, so I'm looking at the frequency response right after the tone stack. It's kind of an interesting place to look at it. And so that's the oscilloscope probe. It goes into here. Going into the amp, I have basically just a cable running from my laptop. So I'm using my laptop as a function generator that's also being controlled by Python. So what it's going to do is it's going to step through a series of frequencies, about 4 different frequencies per octave, and it's going to make a measurement at each one and generate a frequency response for me. And of course the output of the amp is plugged into this handy dummy load here because I don't want to listen to sine waves. I don't think you do either. Anyway, it's pretty straightforward. It's just a little Python script here to get it kicked off. The first thing that it does is it goes into calibrate mode, which basically puts out a 1 kilohertz signal, and it just gives me an opportunity to basically, adjust the oscilloscopes that I'm in just a decent voltage range for what I want to measure. Because this program won't adjust the voltage range for me, but as long as I get it into a rough ballpark, it'll be fine. And then when I'm done with that, just hit enter. And away it goes. You can see it's chugging along there. It would be nice if this were a little faster. I seem to be basically limited by how quickly the scope itself can capture data and send it back to me. It's a little on the slow side. Means my fantasy of a real-time updating frequency response curve is probably not feasible at the moment. This takes about a minute or so to generate one. But when it's done, it pops up. And there's my curve. And now I can use that to correlate what's actually going on with what my ears are hearing, and I can think about what the circuit is doing, and if I don't hear what I want to hear, I can go in and monkey with it until I do. Anyway, just thought that was pretty cool. The code is going to be up on GitHub. My GitHub ID is Chris Rossi.